So okay, we have our second example, just like with the bisection method. This is our second example for the false position method. So purpose na to nung anong similar na to, so we can compare the calculations. No, if we calculate the root of the nonlinear equation using bisection and false position method. So same given, same problem. It's just that um, we are going to use the false position method, and again at each iteration we are going to calculate the approximate relative error and the number of significant digits at less correct at the end of each iteration. So again, we have here the ball, the problem, and then same lagi po natong gamiton. Let's say the lower limit is at 0 and the upper limit, now is assume that the whole ball is submerged, that is at 0.11. So same the function of xl, and let me just rewrite the equation. It is at x cubed minus 0.165 x squared plus 3.993 times 10 to the negative 4 is equal to 0. This is negative, sorry, this is a function of 0, that is 3.993 times 10 to the negative 4, and the function of the upper gas is negative 2.662 times 10 to the negative 4. Since we have established that uh, the functions of the product of the functions of the lower and upper gas is equal to 0, then a root exists between these 2 points. So we just calculate the new root, no, approximated root, using the false position formula. So let me just write this here. So we have the 0.11. So we have the 3.993 times 10 to the negative 4. No, for the false position method, no, importante na itong value for the the functions of the lower and the upper gas, and as well of the approximated root. So we just apply, no, the formula xr is equal to xu f of xl minus the xl times f of xu all over f of xl minus f of xu. So from there we can get a 0.066, and then the f of xr is negative 3.1944 times 10 to the negative 5. Now if we compare the functions of the lower and upper gas with the function of the approximated root, sa ato pa, our lower gas will remain as is at 0, but the upper gas will be the 0.066. So let's write this down. So by the same equation, the false position method, we can have a new root at 0.061, and the new root has a function of 1.2316 times 10 to the negative 5. So sa ato pa, our new lower guess or new lower nga root na to for gamito na to for our interval or the boundary is 0.061, and the upper is 0.066. Our new root is 0.062. And then we have the function at 3.368 times 10 to the negative 6. So karon di ba yung niya 3 iteration. So we are already done with our iteration. So what if we continue this one? So if we continue this one, we'll have again our lower root at 0.062 and the upper root at 0.066. Now at this point, atong makuha na nga root is at already 0.062. Mao na gid na siya atong makuha dayon. So sa ato pa, we have already converged, no, with the correct root. We have already converged with the correct root. Now let's take the approximate relative error per item. The first one is we don't have a previous value of the approximated root, so we just put a dash there. And then for the second iteration, we have at 8%. For the third iteration, we have a 2.05%. And for the fourth iteration, we have a 0. So the number of significant digits for this one is 0. This one is 0. And here for the second one, there is one significant digit. And here, actually this is, there is none. Ang pag-calculate mo ano is, wala kayo makalculate no, it is mathematically error because the logarithm of 0 is, it doesn't exist. So sa ato pa, when this happens, we arrive, it means that we have already arrived at the correct answer. Since we have already arrived at the correct answer up to the number of digits nung ato na consider. Sa ato pa, this is correct up to 3 significant digits. Kung ato pa ni-extend up to 6, so yung ato na makita di ano, up to pila ka significant digits ang correct. Therefore, the root is x is equal to 0.062. Or sa ato pa, the ball is submerged at 6.2 centimeters. And then this will be the answer for this specific problem.